Today we will be learning meter bridge and we will do some practical and we will find the value of unknown resistance using this meter bridge. So let me first of all explain what the meter bridge is and how it works. Actually, a meter bridge works on the principle of a Wheatstone bridge. Now, what is Wheatstone bridge? Wheatstone bridge is a combination of four resistors which makes a rectangle when they are connected with each other. Here we have a rectangular combination of the four resistors. Now, in a Wheatstone bridge, any two diagonally point, any two out of the four, any two is connected with a battery and the remaining two diagonally opposite points are connected to a galvanometer. Now the Wheatstone bridge is balanced. In balanced condition, let me name these resistances R1, R2, R3, R4. Okay. So in balanced condition means current through galvanometer is equal to 0. No current is flowing. Ig comes equal to 0. So in balanced condition of Wheatstone bridge, R1 upon R2, ratio of the two resistances must be equal to the ratio of another two resistances, R3 upon R4. This is the principle of, this is the Wheatstone bridge. Now, how it is related to our meter bridge? A meter bridge makes your work more simpler. Here, out of the four resistors, here you have to connect a galvanometer. A galvanometer is connected at this very point. Galvanometer is connected. One resistor, this is, if you take this R1 and this R2, so here you should take a resistance and call it R2 and R3 upon R4. Okay, here you should take a resistor, you should call it R4, R2. So you have two resistors, just like in a balanced Wheatstone bridge you have two resistors. Now this meter bridge it is more better than a Wheatstone bridge, as the galvanometer is connected with jockey and this jockey can move on this 1 meter wire. Here you have 1 meter wire. Here you have 1 meter wire. So when jockey moves at any point if it is connected such that current through galvanometer, I through galvanometer becomes equal to 0. You have to scroll this jockey on this length. It shows that your R1 and R3 is not fixed. When you scroll this jockey on this 1 meter length wire, at any one point, Ig becomes equal to 0. Then you can say that, okay, your this R1 and this R2 is related to other two resistors in such a way. When Ig is equal to 0, and you can see this is a rectangular mesh. From two terminals, Ig comes equal to 0, and obviously this terminal is connected to a battery. So two vertically opposite terminals are connected to galvanometer and two vertically opposite terminals are connected to a battery. So when you scroll this connection of galvanometer on this wire, and at certain point if galvanometer reading Ig becomes equal to 0, and suppose at this point the resistance of this length is equal to R1 and resistance of that length is equal to R2, then R1 by R2 must be equal to R3 upon R4. Now how you will be obtaining R1 and R2? R1 and R2, okay, this is your R3, okay, this is your R3. Now next thing is to find the value of R1 and R3. Since we know that the wire is uniform, so resistance per unit length is a constant. Therefore, resistance of L1 length. What is this length? Suppose this is L1 length and this is your L3 length. Therefore, resistance of L1 length is equal to, and if this constant is sigma only, means resistance per unit length is sigma, so resistance of L1 length will be sigma L1 and L2 length is equal to sigma L2. Now let me put all these values in this equation. R1 upon R2 is equal to R3 upon R4. Therefore in equation 1, okay, in this diagram only, this is your equation 1. Equation 1. Therefore in equation 1, in place of R1 we will be writing sigma L1, and for, okay, this is your L3 length. Okay. Upon R1 is equal to sigma L3 upon R4. It implies that when you cancel sigma from the two ends, it implies that L1 upon R1 is equal to L3 upon R4. And if you change the notification, you can write that L1 upon R1 is equal to L2 upon R2. So this is the formula of how resistance is related to length in a meter bridge when null deflection is there. Okay. So let us do practical on meter bridge. Let us find value of unknown resistance with using one more known resistance. So in meter bridge we need only two resistance, one known one and one unknown, the value of which we have to find. So here you have a meter bridge. Its construction is very similar to a Wheatstone bridge. The two opposite ends, you can see here, the two wires are coming to a battery eliminator. So here it is supplying DC current at the two vertically opposite ends, and at the center from here a galvanometer is connected, and which this is a jockey that I'll scroll on this very wire, a wire which is kept on 1 meter scale. So while scrolling, finally you will reach at a point so that the galvanometer reading becomes 0. And galvanometer shows the current flowing through this arm. When current flowing through this arm becomes 0, then as per Wheatstone bridge, ratio of this resistance, this upper part, to this resistance will be equal to resistance of this very part of wire to that of resistance of this known resistor. Okay. So, and one more thing, the two resistors, one unknown and other known, these two resistors should be proportional, means the ratio of the two resistance must be nearly equal to 1. If not they are nearly equal, then there will be error in calculations, because they will sum up the end correction, the end errors. If they are not equal, so finally in calculation, when you calculate the end errors, the extra resistance which is due to this stripe, which is equally cancelled, which is when the two resistances are equal. So we should try to have the two resistance nearly equal. So there will be minimum error, and our meter bridge is very sensitive, and it will give in this condition very accurate result. So first of all, let me explain the construction of meter bridge. Here you have 1 meter wire, and then you have thick metal stripes. These metal stripes are made thick so that resistance of this part become nearly equal to 0. All these metal stripes have resistance nearly equal to 0. So you have along this side, you have two resistances, one unknown resistance and one known, which I have taken as 1 ohm. And on the other side, you have resistance on this 1 meter long LY wire, which is made up of manganese, constantan, nichrome, etc. These are made up of alloys. These have high resistivity and very low temperature coefficient of resistivity. So keep it in mind. Very important questions these are. Two things you need to remember. Firstly, the ratio of this known resistance and unknown resistance should be nearly equal to 1, so that the error due to end resistances, due to resistance along the two ends, should be exactly cancelled. Then only your result will be a very authentic one. Firstly, we need to check that the deflection along the two ends of your meter bridge should be along two opposite sides in this galvanometer. Here you can see deflection is on this side. Okay. Now when we touch the jockey on another end, you will see deflection is on other side. So it is clear that in between you will have one null point when the deflection is neither one side nor another side. The needle will be exactly at 0. So let me start measuring the length of this resistance. So let me scroll from one side. On scrolling, when you go on reaching near somewhere, okay, at this point, yeah, at this point you can see deflection is 0. So let me switch off first of all and note down the length. Here length is your 59 centimeter. L1 we obtain 59 centimeter. Now next time I will be scrolling from other side. So I am scrolling from this end, and again I am observing the null deflection. Yeah, here I get null deflection at this point. Good. So this time I am getting length from one end of 60 centimeter. From one end it is 60 centimeter. Now again I will be taking 4 readings. Now this time I will be scrolling from this one end. Yes. You have null point at 59.2 centimeter. 59.2 centimeter. And last reading I am going to take by scrolling from the other side and observing what is the value. Okay, here we obtain null point. At null point is obtained exactly at 59.8. Okay. Now let us calculate the readings for finding the value of unknown resistance. So here we have reading. We have taken 4 readings for length L1 and corresponding length of L2. And L2 will be equal to 100 centimeter minus L1. So, and then I took average of all these 4 values, and so L1 came equal to 59.5 on average L1, and average L2 came 40.5. Now, for null deflection in galvanometer, we know that in a meter bridge, R1 upon L1 must be equal to R2 upon L2. And I put the values of all the known things and to obtain R1. So R1 comes equal to 1.46 ohm. We see that using a meter bridge to know the value of one unknown resistance, we know we need one more known resistance, and we can find the value of unknown resistance.